Okay, and then for the next question, well, I don't really have enough space, so I still need to keep my head hidden. It's gonna be a word problem, and it's gonna be a word problem on intervals. So this is a very interesting scenario. Jill is now 27, irrelevant, and she has got 4 pictures to hang in a horizontal row on a wall, which is 4,800 millimeters wide. So you can imagine a wall that is 4,800 millimeters wide. And these pictures are identical in size, which are 420 millimeters wide. One is on the extreme left, so there's where it goes. One is on the extreme right, so there is where it goes. And then the remaining 2 are placed such that all 4 of them are equally spaced. So let's say here and here. All right. So let's pretend that they are equally spaced. So the question is asking you, how far should Jill place the center of each of the 2 remaining pictures from a vertical line down the center of the wall? So we are actually looking for the distance between the center of the painting and the center of the wall, right? So for the distance between the center of the painting to the edge of the painting, we can find it by the width of the painting divided by 2, because that's going to be half of it, right? So it will be 210 millimeters. All right. And what about the distance from the edge of the painting to the center of the wall? That's going to be half the gap, right? So you can imagine that this is going to be half the gap. Say it is W. So this is, each gap is going to be 2W, right? And all the 6 W's added up is going to be the total width of the gap, which is the width of the wall, take away the width of the 4 paintings, and then you divide it by 6, such that you can see that it's going to be 520 millimeters. So that's W. So altogether, the distance from the center should be 210, adding 520, which is 730 millimeters. So the answer is going to be C. All right. And then the next question, 22, unfortunately, I still don't have enough space, so my head is still up there. So this is a geometry question, and it will be on cutting regular polygons again. So how does this work? First of all, we can try to cut this hexagon into 18 pieces with equal areas by doing this. Okay, so this is a pretty long process, but then once you have finished it, you will see that all the triangles that are resulted are having the same area. So they are either the equilateral triangles in the center or these obtuse triangles up the edges. Each of them has area 1/18. And that's because you can see that the base of the obtuse triangle and the equilateral triangle are the same. The height of the obtuse triangle and the equilateral triangle are also the same. So they're going to have the same area. Okay? Which means that now, if you are just considering the core, like there's a 6-pointed star in the core, it's going to have an area of 12/18, which is equal to 2/3 of the total area of the hexagon. And then, what fraction of the core is shaded? Well, we just need to do a cut like this to cut the core into 6 identical rhombus pieces. And in each of these rhombus pieces, you can see that 1, 2, 3, 4, 5, 6 parts out of 8 are shaded, right? Which means that the total shaded area, or the total shaded fraction, is going to be 2/3 times 6/8. So if you're just simplifying it a little bit, you can see that that's going to be a half. So the answer is going to be 1/2. Okay? So that's how we can solve this question, by cutting it up. And question 23. Still, I can't put my head onto the screen because, again, it is occupying very much of the space. So it is, again, a geometry question. And this time it's on inclusion and exclusion principle. So what do we have for the inclusion and exclusion principle? We know that the combined part has to be equal to the separate part. Take away the overlapping part, right? Okay, so that's a little bit too much. Separate. Take away the overlap. Okay, so now let's look at the dimensions we can see in this diagram. So the smallest one must be having an area of 1 centimeter squared. That is 4, that is 9, and that is 16. Yeah, which means that this is going to be 3 centimeters. This is going to be 2 centimeters, which are the side lengths correspondingly. This is going to be 3 centimeters. This is going to be 1 centimeter. But then what is the remaining part? It says that the unshaded part is 1.5 centimeters squared. So this is 1.5 centimeters squared with a base of 1, right? So this is also 1 centimeter, which means that the length is going to be 1.5 centimeters. So now we know that for this whole rectangle, the width is 5 centimeters and the length is 5.5 centimeters. So now we can do the analysis for the inclusion and exclusion principle. For the combined part, we can see that it's the area of the rectangle except the blank part, right? So you have 5 times 5.5, take away 1.5. And that's going to be 26 centimeters squared. For the separate part, it is going to be 1 adding 4 adding 9 adding 16, because that's the separate area of the 4 squares. And that is equal to 30 square centimeters. And what is the overlapping part? That is what we are trying to find, right? So that's going to be having 26 centimeters squared equals 30 centimeters squared, take away the shaded area. So what is the shaded area? 30 take away 26. So the answer is going to be 4. Okay? That's how we get the answer for this question 23. And as for question 24, I can finally put my head onto the screen again. So this is a number theory question. And I would say that is on divisibility. First of all, we need to know that whatever number divisible by 45 has to be divisible by 5 and divisible by 9, because 45 is 5 times 9, and 5 and 9 doesn't have any common factors. Or in other words, they're co-prime, okay? So, after that, we can just try to see how this number works. It says that it's a palindromic number, which means that it reads the same when the order is reversed as when it's normal. Which means that it's going to be looking like something like A, B, C, B, A. Right? So let's say this is the 5-digit palindromic number, A, B, C, B, A. So now it has to be divisible by 5. Alright? Which means that A is equal to 5, because it can't be, well, for anything that is divisible by 5, it ends with 0 or 5. But then a number cannot start with 0, right? So it has to be 5 if it wants to be divisible by 5. So then I have the number 5BCB5. All right, and now I want to find the difference between the smallest and the largest possible such numbers. So if you want this number to be as small as possible, of course, you want the largest digit to be as small as possible, right? But since now we have the 5 there already, the largest digit I can change is B. So for the smallest possibility, B is just equal to 0. So we have 50C05 as the number. And it needs to be divisible by 9. For a number to be divisible by 9, we know that all the digits added up, it has to be divisible by 9 as well, right? So 5 adding 5 is 10. Which is not divisible by 9. What is the next multiple of 9? That's going to be 18. So C is equal to 8. 18 take away 5 times 2, that's going to be 8. All right. So it means that the number, the smallest number, is 50805. And then for the largest, we are just using the same logic. If I want it to be the largest, I want B to be 9. That's the largest digit I can use. So the number becomes 59C95. So now, I want it to be divisible by 9. But 5959 adds up to 28, which is again not divisible by 9. What is the next multiple of 9 after 28? It is 36, right? Which means that I need to add 8 more. Which means that again, C is 36, take away 9 times 2, take away 5 times 2, which is 8. So this answer is 59895. Now, I'm looking for the difference between them. So I just need to subtract. Let's say I'm subtracting 59895. 50805 from 59895, and I got 9090. Okay, so the answer is B, 9090. That's how we can solve this one, question 24. And finally, question 25. Again, I don't have enough space. So this is, I would say that this is pretty challenging for, you know, boys and girls at your age because it's a lot of letters there, representing the unknowns without any solid numbers that you can calculate on. And very oftenly you need to find the conditions on your own. So I would say that it's on the angles and lines. Also, it includes the knowledge for using letters to represent unknowns. So this is both related to the geometry module or like the algebra module, both of them. Okay. So first of all, we want to find x in terms of y and z. So you can see that x is right there, y is right there, z is right there. Well, z is pretty much far away from y and x, right? But then for y and x, is there any way I can join them together? So if you still remember the rule about the exterior angle equals the two non-adjacent interior angles, we know that angle angle YWX, which is this one, adding x is equal to y. Because the exterior angle of a triangle is equal to the sum of the two non-adjacent interior angles. So now the purpose of this question becomes finding an expression in terms of y and z for this angle YWX. So quickly we can see that VWU is equal to angle YWX because they are vertically opposite angles. Okay, so now the purpose of this question becomes looking for VWU, which is a bit easier for us now because you can see that VWU is in this isosceles triangle. According to the question, these two edges are the same, right? So if I know the top angle, I will be able to express this base angle as well. So what is the top angle? We can see that this is Z, this is Y. So the top angle must be 180 degrees, take away Z degrees, take away Y degrees. That's the interior angle sum of a triangle, adding up to 180 degrees. So if you remove the two other angles from 180, you get that top angle. And now what about the base angle? So again, you can make use of the fact that the interior angle sum of a triangle is 180. And also, remember that the two base angles of an isosceles triangle has to be the same. So it means that if you are taking away the top angle, which is 180, take away Z, take away Y degrees from 180 degrees, which is the angle sum of this triangle. And then you divide it by 2, you will get angle VWU. So if you just simplify it, the 180 take away 180 will cancel out, which means that the angle VWU is Y degrees adding Z degrees divided by 2. So this is equal to angle VWU, which is also equal to angle YWX, right? Which means that I can now replace this with this. So now we have Y adding Z divided by 2, adding X equals Y. So of course, if I want to find X as the subject of this equation, I'm just taking away this from both sides. So I have Y take away Y adding Z divided by 2, which is equal to 2Y take away Y adding Z divided by 2, because Y is 2Y over 2, right? Oh, one mistake there. It should be take away Z as well, because when I'm removing the fraction, I'm removing it as a whole. So that's going to be y take away z over 2. Okay? So the answer is E. All right? So hopefully this is understandable for you, because that requires a lot of foundation on algebra. So if you're not strong enough in algebra, I guess it's hard for you to solve this question. Well, so that's it for this question, and that's it for today. Thank you very much for listening, and I will see you next time. Okay? Bye bye.